I got my PhD back in 2007, and my PhD in microbiology. I worked. My dissertation was chlamydia infections on human macrophages. So human macrophages are part of the immune system. After that, I worked at the Cornell University for 3 years, and I studied chlamydia infections more. And then after that, I moved to the University of South Carolina School of Medicine to study Mycobacterium tuberculosis infection on the human macrophages. So I've been a macrophage guy for a very long time. And I work with a lung pathogen. Mycobacterium tuberculosis is a lung pathogen. And yeah, I've been in the infection biology for almost like 10 years, 15 years so far. This is what I want to share. So what I'm trying to explain over here is what's happening when you're exposed to the coronavirus. So first, I would like to talk about what our systems looks like, how coronavirus is going to invade. Basically, when you're taking a look at these systems right over there, so this is our lung systems and respiratory area over there. And if you have, if somebody cough to you and who are contracted with coronavirus, and this little virus is coming out, and it is normally going into your nasal cavities over there. So once they get to there, and they're going to go all the way down to the lung area, especially they're following to the trachea, and then finally they're getting into the bronchis. Bronchis and the bronchioles are smallest branch of these lungs. And at the end of that, bronchioles, we have alveoli over here. So this alveoli, when you take a look at the alveoli, and this is what they look like in a bigger versions. So the function of this alveoli is basically exchanging O2 and CO2. When you're breathing, so O2 will get there. When you're breathing out, CO2 is out of it. So this is a place where you exchange O2 and CO2. So this is alveoli. When you take a look at the surface of this alveoli and all those lung area bronchioles, and when you look at under the microscope, they are basically having this epithelial cells are connected to it, all over it. And they have a nucleus over here. And then some of them, some of those cells look like this, and they are making mucus. And many of those, the cells have a cilia like that way. Cilia like that way. So once you have that kind of systems going over there, and this goblet cell, this is a goblet cell, will make a mucus. And so your surface area is sort of like covered with this slimy mucus over there. Slimy mucus over there. So once virus actually get into the systems, and they are going to come down to the bronchioles, and they start to infect it over that area. However, it's not really easy for them to do. So if you are very healthy, and if you have very well intact immune systems, and in this case, I can say innate immunity, if you have very good immunity that you are born with, such as like this mucus productions, and also is you know, the secretions in the nose, and also nose hairs, those are all part of the providing the immunity that we're born with, basically. So they have a lot to get through. First is nose hair and those secretions on the nose, and then once you get over it, and you have to go all the way down there, and somehow you have to penetrate this mucus with ciliated cells. If you have adequate amount of mucus, if you have too much, you have a hard time to breathe. So that's another sign of you may have some underlying disease. But if you have just the right amount, this virus comes down to it, they are going to be coated with the mucus, and this cilia on these ciliated epithelial cells will whip that out of the systems. So like you know, sometimes you're just coping the mucus out. So in that way, you're whipped those virus out of the systems. So these are all part of the protection system that we can provide in the first place. And once that has been done, you're probably not going to have a lot of, the virus remaining in your body. So you probably would not really even feel that you're infected or anything like that. However, if you don't have enough mucus, let's say we are in a very drying season, for example, during the winter, a lot of mucus going on over there. We don't have a lot of mucus going on over there, and rather we have something like just a very thin layer of that. And let's say you are a smoker, or you have been exposed to the heavy pollutant, then you don't have a lot of cells that has a cilia on it. And this is a great opportunity for the virus to start to infect these epithelial cells around there, unfortunately. Then what's going to happen is once you get infected this epithelial cell, they're going to start to replicate over there. Coronavirus does not kill the cells. They leave them behind, but once they get out of these infected cells, they are infecting neighboring cells. Once this is going on, what's going to happen to these epithelial cells is basically they're going to start to send out the emergency signal out there before we actually get there. So once they replicate, and some of them will come out and infect in the upper place over there, some of the virus will come out of there in this way. Once they come out of there, and underlying of these epithelial cells, we are having another innate immune system, which is run by the cell called the macrophages. And another set of cells called the NK cells. The NK cell is like a patrol officer. So if you see some of our cells are struggling like that, and they approach it to them and getting rid of those struggling cells very peacefully. So those cells are out. Now, here comes the thing. So when I talked about when you first asked me questions, how about the food that helps our immune system? So if one of our immune system is quietly getting rid of one of the cells that are suffering, then stem cells has to come over here and fill that out by differentiating to these epithelial cells. So that part can be helped by lots of vegetables eating. So we can provide a lot of bioactives for the stem cells to move to differentiate and fill that gap. Does that make a sense? Mm-hmm. I feel like I'm just running, so I'm just checking on you. That okay, so that's one of that. So we have this NK cells and macrophages. We are over there, and if those NK cells and macrophages, if macrophages recognize this guy, they are peacefully getting rid of these viruses into the very small molecules. So it's not harmful at all. So if you have enough of these macrophages and NK cells, then we are probably not going to feel a lot of harsh symptoms, basically. So it is important for us to have very sound, the innate immunity anyway. So however, if you have a lot of viruses comes and replicate within the systems, so we are kind of outnumbered over there, and then we don't have enough of these NK cells and macrophages, some of those viruses can even use the macrophage to replicate too. Because as I said, macrophage is overwhelmed. All the cells in that area basically has these the limitations, and they have life expectancies. So if it is not replenishing in a way, then virus can infect and comes out of it. If you have a lot of cells are basically infected by these viruses, and these epithelial cells over there And these macrophages over there, that has been used as a reservoir for the viruses, and they are sending out the signal called the cytokines. These cytokines will go through the all the way down here. There's a blood vessels going on over here, and blood vessels going over here, and then these cytokines will get into the blood vessels and asking for the help. Then we're gonna bring the firefighters there, such as like neutrophils. So these immune cells and other fighter immune cells, they are really a fighter. I mean, like, you know, have you ever seen boxing game before?
Mm-hmm.
There's the guy like in fighter, even though you are getting a lot of blows and you still keep going. That's the in fighters. So these immune cells, neutrophils and other fighter immune cells are like that. They don't care it's a virus or our own cells. If you are infected, even though it is our own, they're all enemies. So what they're gonna do is they're gonna start to kill everybody here, basically. Then what's gonna happen is a lot of if you're killing the cells, and you're gonna generate a lot of fluid, like a pus. And because you're bringing a lot of immune cells there, and this area, entire area over here is swollen. And if these fighters come and fighting, while they're fighting, they also send out another cytokines to the blood vessels, bring more those fighters in there. So in a way, we are breaking everything down here, which is called a cytokine storm.
Mm-hmm. And that's a term that I've heard talked about quite a bit.
Yeah, absolutely. So this cytokine storm is basically killing our cells. This is the overreact. Oops. This is the overreacted. Oops. This is the overreacted inflammation. So inflammation is the way that we are taking care of infections. But if it is overreacted by cytokine storm, we're gonna kill everybody. So if you are killing everybody, and in a alveoli, what we are gonna put is we're gonna have a result of this fighting, which is lots of fluid and lots of waste has been generated by this fighting over here, and there is no place to pick up the oxygens. There is no place to, if this alveoli does not pick up the oxygens, then that oxygen will, if they are not picking up the oxygen, there won't be any oxygens in any other body organs. So we are dying of multiple organ failures.
And do we know why this happens in certain people? Why their immune system kind of goes into overdrive?
That's a very good question. I don't think we actually know the answers for it. But one thing that we know is this could happen to anybody. So I just checked certain things this morning that for the people who's driving these cytokine storms, basically they have this something called a tocilizumab, which is a monoclonal antibodies that actually can take care of this cytokine storm. So cytokine is absolutely needed, but it needs to be balanced. It needs to be balanced. If it is a cytokine storm, it's too much comes in. And this drug right there will be reducing those cytokine that has been come through too much. Because if there's a cytokine, there will be more fighter immune cells there. And that is going to kill everything over here. So, yeah.
So, you know, you could be ahead of the game in terms of like, you know, your biology, like if you have the right mucus production, nose hair to try and keep those out, and
Absolutely.
your immune system is strong, but what if they still get in, and then you could this cytokine storm could happen?
Well, unfortunately, even though you're very up to the game about this, and cytokine storm happens, then unfortunately you're going to go through the courses, that severe courses of this viral disease, unfortunately. So one of the things that we can all avoid this is if we have these guys are more ready on our system, and if we're making this the mucus production is about adequate amount of that, and if we're blocking that there comes through, we're going to be able to survive. That was my point anyway. Mm-hmm. And another important thing is, if we are, even though, let's say, if we can delay the start of all this for like 14 days, while we are fighting, if we are up to the level that we can fight well without going to the coma or anything, then 14 days later, our body can provide an antibody. And antibody will neutralize this virus very quietly. So then question becomes, what should we do then? So this is how we're gonna die. And we have to survive for 14 days, right? And the most important thing is not to be exposed to the virus at all. That's the most important thing. That's one of the reasons why we have to cover, we normally call them as the dangerous T-zones, but we have to cover your eyes, and especially nose and mouth over here. We have to cover them very well, and that's the most important thing. And you have to bring your own the hand sanitizers, the sanitizer all the time. That's also very important. And because as far as I know of, and virus can, if you are, so let's say you and I are in the same room, let's say about like, regular room, and I sneeze, not sneeze is not too much, but if I talk to you and I'm infected with this virus, then this virus is going to be stay in the area for 3 hours for sure, being active. And if it is onto the some of the plastics, and if they are stick onto the plastic, and it's going to go for like 72 hours. So if you have sanitizers, and if you have the antimicrobial wipes, you wanna wipe them off. And plus the boxes, if you order something from the Amazon, boxes are coming. First thing that you have to do is using some sanitization chemicals to wipe them off, because that can stay there for 24 hours. That kind of information is already in a website, and I'm just pulling out the website over here, and this actually shows you how long does coronavirus last on the surfaces. Based on this, we have to sanitize them, using the sanitizing chemicals, and once those boxes are coming, we have to sanitizing them, and that's very important. So that's a
would it be okay, just like I've heard, just leaving the box on your doorstep for 24 hours and then maybe opening it up and taking the item out and then disposing of the box?
Well, that could be another good way to do it, yes. So it's 24 hours is a critical point. Still though, even though it is after 24 hours, there's a slight chance some of them may be able to survive. So you don't want that. So I would still use the chemicals, 70% alcohol, the rubbing alcohols you can buy easily, and that's what I would use to spray them and making sure you wipe them off. And then in my case, what I normally do is, even though when I bring those the grocery shopping bags, I normally use the 70% alcohol to wipe them out before I move into my car, basically. So sometimes that could be helpful. And the most important thing, you should not be exposed at all. That's most important. That's number one. Second, let's say they got into the systems over there. We have to make sure that we're not really in a drying area, cold drying area. We'll make this mucus thinner and dry. That gives virus to a very good chance to colonize our lung system. So drinking water is very important in a day, 1.5 liter at least. So that's like the gold standard to have a water, especially we are in a drying seasons. That's most important things. And you probably don't want to go too much cold area, and you don't want your spaces too cold, because there's a cold makes a drying environment. That's not really good. So another important thing is make sure that this NK cells over here and the macrophages, that's part of our innate immune system, and up and running quite okay. That's another important thing over there. So one of the things that you probably saw a lot of or heard a lot about the supplement before, right? And there's some supplement to helps the immune system. They're all right. I mean, like they are not saying anything wrong. But one thing that I think it has been shown, especially for the viral immunity, is a vitamin D.
Now, would you have to take a supplement, or could you get that vitamin D through food?
Yeah, you can get the vitamin D through the food. And most natural way to get a vitamin D is it's a sunny out there, you go outside. And that's the best way. So if there is a sunlight, then our skin will go through the cholesterol, go through the the processes to generate the vitamin D3. So if you are taking it as a supplement, what we are taking, I believe it is vitamin D2. Anyway, they are working in the same way. This vitamin D2, vitamin D3, they are very important for the differentiation of the macrophages. And I talked about how much macrophages was important for us to have. So one thing that has been shown is vitamin D3 and vitamin D2 can differentiate the macrophages. So this is something that I would get it. And the important thing is right now it's a perfect time for us to get out and get some workout done. So one of the ways that important for macrophage differentiation would be you have to have, so macrophages are always differentiated from something called a monocyte. So those monocytes are circulated in the blood, and when they get into the certain tissues, if they get the signal, and they are differentiating to the macrophages. So with coming with the right signals, if you have a vitamin D2 or D3, they will help you for those monocytes that has been getting to the lung area to differentiate to the macrophages. So if somebody asks, well, I heard there are a lot of supplement out there as an infection biologist. What kind of supplement do you want to have? And if you just ask me like one supplement, vitamin D would be my bet. But it's just my opinion. Everybody reacted differently, but based on research, and this is one of the things that actually been shown. Another thing that I found is very interesting was, you still able to see my screen?
Mm-hmm.
Okay.
And just a quick heads up, we only have probably about 5 minutes left on our timer. So if we need to, we can schedule a little more time together too.
Okay, I think I can wrap it up pretty quickly over here.
Okay.
One of the things that that I found is very interesting is it's not about. Can you see this the document over here?
Mm-hmm.
Okay, so this is not about COVID-19 causing SARS coronavirus 2. We are not talking about that, but the ancestor of that virus is a SARS virus that has been on to the 2002, and the zinc ionophore right there. Zinc is actually showing that right over here. If you are having 100 micromolar, if you're treating the cells with 100 micromolar, and their RNA has a hard time to be replicated. This is the data exactly showing that. So even though we don't know this zinc will work for the COVID-19 SARS coronavirus 2, if you feel better having the zinc, I would not be against for it. And last thing is exercise. If you wanna, so even though you're training really hard, let's say some of us training for the marathon or something like that, if you're not going to be exposed to the other people who had the coronavirus, then I don't see why you should not do the exercise like that. But if you know you're going to contact with a lot of people very next day, I would cut back a little. Exercise is important because that's one of the way that your heart is pumping, so your blood is circulating, but you should be able to very comfortable with your amount of exercise, so you're not going to be overboard, for sure.
Because, distance runners, like when you're training for a marathon or half marathon, that, stresses your body and,
right. That's
it can wear down your immune system.
Absolutely.
So that's why I'm wondering if you should kind of cut back on your exercise maybe a little bit, maybe not.
Right, but if you know that you're going to expose to the other people, because these days coronavirus ranges from the asymptomatic infections from the symptomatic infection, which I can't really get my head around, because if asymptomatic infections happens, that means historically virus has been weakened. But in this case, that's not the case. So anyway, we don't know who has a virus. So if you know you're going to go to work very next day and interact with a lot of people, then you should not really do those. If you know that's going to happen, that you probably have to cut back a little.
Okay.
But you're going to be isolated by yourself for about like a week or so, and typically, if you're wearing out your immune systems by working out a lot, that normally get back up to the normal level in 48 hours normally. So if you know that in 48 hours you're not going to be exposed to the other people, why not?
Okay. And then what about in terms of sleep?
Sleeps are very important. I'm glad you say that. Sleeps are most important. I can show you other studies that has been already done it. I should have over here. Sleep and innate immunity. You see it? Sleep and innate immunity. If you are asleep if you are sleeping the lower than 5 hours, that's crazy. And your innate immunity is the one that we talked about here. So around here, so that the NK cells and macrophages and those mucus productions are all strongly related to the sleep. You need to sleep well, and also you need to get into REM sleep, not just for the innate immunity. They are also very important for is antibody production as well. So sleep is most important. That actually connected to the don't get stressed. Stress and sleep are connected very well together. If you get too much stress, you cannot get, in my case, I can't sleep well. So a lot of people can't sleep well. It's tied, very connected. And also, stress hormone that comes out from your the pituitary gland is dampen your innate immunity. So you should not get the really high stress. And also, if you have a depression, you need to go to the doctor, because the depression is dampening both innate immunity and antibody production. Another name of that is called adaptive immunity.
So what is the length of sleep that you should shoot for?
If you can get into the REM sleep in let's say in 5 hours, that's awesome. But a lot of people that has been shown, so that it all depends on people. If you can sleep for like a real REM, rapid eye movement to sleep, if you can get it in a very short period of time, people always say the quality is more important than quantity. I definitely agree with that. So if you can get into that sleep very fast, it doesn't matter how long you sleep.
Okay, so REM sleep, that's when you dream, right?
Right.
So if you're having dreams,
whether you remember it or not, because if you wake up in the middle of your dreaming, then you're going to remember a dream, right? Yeah, you got to ask to the sleep expert for that.
Okay. Okay, anything else you think would be important for people to know?
T-zone. T-zone. So you have to wear, so ideally, this would be the way that you go to the grocery store. Ideally, that. This is the ideal way to go to the grocery store. So this dangerous T-zone, I don't go to grocery store these days like this. I go like that at least.
Mm-hmm.
But you know that in ideal way, if we are, if you want to protect yourself completely, then this is the way to go.
Just a heads up, we have less than a minute, so we may get booted here pretty soon. I apologize. This has been great information.
Yeah, I hope that this helps anyway. You know, probably I go a little overboard. If I did, I'm sorry, but I kind of hope that people know what's important, basically.
Yeah, no, I think this will be really helpful. You know, the way that you explained it with the diagram and everything. So